Welcome back. In this chapter, chapter 7, we're going to be talking about chemical formula relationships. We're going to start by talking about determining the number of atoms in a formula. And we've already talked about this briefly before. Whoops. And what we want to do here in writing the formula of a substance, as we've seen, subscript numbers are used to indicate the number of atoms or groups of atoms for each element in a formula unit. And we saw previously that there's an exception. If that number is 1, the 1 is omitted. So like I said, we've already done these examples maybe before, but let's look into it a little more carefully. So the example problems here are how many atoms of each element are in a formula unit of, and then it gives several examples here. So we're going to have to take what we learned about writing the formulas of ionic compounds in chapter 6. That's why that chapter is so important, to apply it to this chapter. So let's write the formula of ammonium carbonate. Okay, so you can look at your table of polyatomic ions for this, but the formula for ammonium carbonate is NH4 CO3. Okay, and you can go back to our chapter on naming these ionic compounds to figure out how I got that if you're confused. Okay, but this is the formula of ammonium carbonate. Okay, so ammonium ion and a carbonate ion. And so we want to figure out how many atoms of each element we have in this formula unit. So what I like to do is I like to just write down my different elements here. So in this formula unit, I have nitrogen, hydrogen, carbon, and oxygen. Okay, and then I'm going to write down how many of each I have. So for nitrogen, right? Well, I have 1 nitrogen per ammonium ion, but remember this subscript 2 tells me I have 2 ammonium ions. So you just multiply, there's an imaginary 1 there, 1 times 2, so I have 2 nitrogens here. Same idea with the hydrogens, okay? I have 4 times 2, you just multiply the number on the inside of the parentheses by the number that's on the outside of the parentheses here. So I have 8 hydrogens. Again, there's 4 per ammonium ion, and I have 2 ammonium ions. Okay, for carbons now, I just have 1 because there's that imaginary 1 there. An imaginary, I guess, it's omitted, I should say. And then here I have 3 oxygens. Okay, so this might seem pretty easy, and I hope it is, but as we go on to getting the mass of these compounds, it's going to be very important that we know how to do this and do this correctly. Okay, so again, we have 2 nitrogen, 8 hydrogen, 1 carbon, 3 oxygen here. Okay, so magnesium chloride, well, here we go. If I write the formula, I'll just write the ions real quick, just so we have practice. You cross those guys, right? So this is the formula for magnesium chloride. Okay, magnesium had a 2+ charge. Chloride ion had a 1- charge. Okay, so this one's easy. I have 1 magnesium ion and I have 2 chloride ions. Pretty easy. Okay, so why don't you pause the video and try to do the next one, barium iodate, and then we'll do it together. Okay, so writing down the formula for barium iodate, excuse me. Okay, this is what the formula looks like. So again, what I'm going to do is I'm going to write down the elements that I have. I have barium, iodide, and oxygen. I have 1 barium. I have 2 iodides, and I have 6 oxygens. Okay, so hopefully that was clear, and that's pretty much it for this section. We're going to apply this and do this over and over and over again as we find the masses of these compounds, and that's what we're going to do in the next video. So see you there.